What if I told you the scariest thing in the universe isn't a black hole or an alien invasion? It's a single beep-a-short, unexplained signal that cuts through the endless silence of space. It's not loud, it's not flashy, but it's there. And scientists all over the world are scratching their heads wondering who or what sent it. For decades, astronomers have been listening to the stars. And while most of what they hear is just the static of dying suns or the rumble of exploding galaxies, once in a while, something breaks the pattern, at a sound that shouldn't be there. A burst too powerful to be natural. A frequency too precise to be random. These aren't science fiction fantasies. These are real signals. Recorded, verified, still unsolved. Let us dive into two of the most spine-tingling cosmic signals ever picked up by our ears on Earth. And we'll begin with the one that made a scientist literally write, "Wow." In the margins. Number 10. The wow signal, a perfect ping from the stars. It was just a normal day at Ohio State University. Astronomer Jerry Emmon was going through pages of data collected by the Big Ear radio telescope. Back then, this data was in T-digital. It was printed out in long columns of numbers and letters that represented radio signals detected from space. Most of it was boring, until he saw it. A 72-second-long burst of signal at exactly 1,420 megahertz, the radio frequency emitted by hydrogen. The most abundant element in the universe. But here is what makes that frequency special. Scientists have long believed that if extraterrestrial civilizations wanted to communicate, they'd use that very frequency because it's universal. Hydrogen is everywhere. It's a kind of cosmic language. So when Jerry saw that signal, he circled it in red ink and scribbled one word beside it. Wow. The name stuck. And to this day, it remains one of the strongest candidates for a signal from intelligent life. The wow signal wasn't just strong, it was precise, didn't drift in frequency. It didn't fluctuate wildly. It was sharp, clean, and shockingly consistent with what scientists expected from a deliberate transmission. But then, just as quickly as it arrived, it vanished. It never repeated. Not once. Despite countless efforts to detect it again from the same location somewhere in the constellation, Sagittarius C has remained completely silent ever since. Some skeptics have suggested it could have come from a passing comet, or maybe even Earth-based interference. But those theories have never quite held up. For one thing, no known comet at the time was transmitting at 1,420 megahertz, and the Big Ear telescope had a dual-horn setup, meaning if the signal was from Earth, it would have been picked up by both detectors. It wasn't. It only appeared in one, which means it came from out there. Somewhere, and that's the haunting part. Because if someone did send it, whether by accident or on purpose, they did so over 120 light-years away. That signal took more than a century to reach us, and whatever or whoever sent it may not even exist anymore. Number 9. The Lorimer burst. A flash louder than galaxies 30 years after the wow signal. Something even stranger happened. In 2007, a young undergraduate student named David Narkovic was working with his professor, Duncan Lorimer, analyzing archived data from a radio telescope in Parkes, Australia. They were looking for signals from pulsars, rotating neutron stars that emit regular radio pulses. But instead of a slow, rhythmic beat, they found something terrifyingly loud. A single milliseconds-long radio blast that was brighter than anything they'd ever seen. It was short, just 5 milliseconds. But in that blink of time, the signal released more energy than our sun does in a month. Think about that. All the energy the sun throws out in 30 days compressed into a tiny flash. Scientists named it the Lorimer burst. And it was the first of what we now call fast radio bursts, or FRBs. Here's the kicker. The burst didn't come from our galaxy. It came from 3 billion light-years away. That means the explosion, whatever caused it, happened when Earth was still covered in single-celled life. The signal traveled across unimaginable distances of space and time, only to arrive just when we happened to be listening. Talk about cosmic timing. At first, many dismissed it as a glitch, computer hiccup, a stray reflection. But the data was clean, and over the next few years, other FRBs started popping up. Dozens, then hundreds. Most were one-time events arriving, screaming, and vanishing forever. But some began repeating, And those repeating FRBs weren't just noise. They showed patterns, intervals, structures. Some even changed polarization. As if passing through magnetic fields, perhaps near massive black holes. To this day, scientists still don't know what causes FRBs. Some say they're neutron stars collapsing. Others think it's highly magnetized stars cracking under pressure. But here's where things get spooky. A small but growing number of astrophysicists think some of these bursts may not be natural. Why? Because a few FRBs, especially the repeating ones, come in frequency patterns that look ... encoded, too ordered, too intentional. What if it's a message? What if it's like a lighthouse beam from another galaxy, flashing a signal in our direction every few months? Hoping someone out there is smart enough to pick it up? It's not just science fiction anymore. It's a Canadian hydrogen intensity mapping experiment. This telescope has logged hundreds of FRBs, and among them are a handful that seem to come back again and again. Always from the same spot, always with the same power. Always spaced just far enough apart to make us wonder, is something watching? Part 2. The messages that keep coming back. Most strange signals from space are fleeting. A sudden burst, a few seconds of confusion, then silence. But what happens when something out there doesn't just speak once, but keeps talking? When a signal keeps coming back, in patterns too complex for nature to explain, it forces us to ask a bigger question. What if someone or something is trying to have a conversation? Let's look at two of the most unnerving repeaters ever detected. One came from a tiny, faint galaxy billions of light years away. The other came from nowhere we could even see. Both have scientists checking their data twice, then 3 times, because the implications are staggering. Number 8. FRB 121,102. The signal that refuses to stop it began quietly. In 2012, the Arecibo Observatory in Puerto Rico, yes, same massive dish from movies like Contact, picked up an unusual burst of radio energy. At first, it looked like another fast radio burst. Strong, fast, gone. No one expected it to come back. FRBs almost never repeat, but then, in 2015 it did. Again and again. In the years that followed, FRB 121,102 became the first known repeating fast radio burst in history. It didn't just break the rule, it rewrote the whole book. Unlike other FRBs that scream once and disappear forever, this one kept calling, sometimes weeks apart, sometimes days. And then, in 2020, something even stranger happened. The signals started arriving on a fixed schedule. Every 157 days, like clockwork, the signal would go quiet. Then wake up and blast Earth with bursts of energy again. It was like someone flipping a switch, on, off, on, off. That kind of regularity doesn't happen by accident. It suggests a rotating object or an orbiting pair or something intentionally repeating a message. Some scientists believe the signal might come from a magnetar, near a massive black hole in extreme and chaotic environment that could distort and focus radio energy. Others say the precision of the signal cycle suggests something engineered. And here's where it gets weirder. The signal doesn't come from a bright, active galaxy. It comes from a tiny dwarf galaxy over 3 billion light-years away, a place with barely any stars. Not a location you'd expect to host advanced life for any life at all. Why would a signal like this, so powerful and persistent, come from such a quiet part of the cosmos? That question has no answer. But FRB 121,102 has opened a door no one expected, because once we realized one burst could repeat, we found others. Several new repeating FRBs have since been logged by the CHIME telescope in Canada. And while most don't follow perfect schedules, they all do the same unsettling thing. They keep talking, and we still don't know what they're saying. Number 7. Second HGBO2 +14A. A signal from nowhere. If FRB 121,102 is strange because it comes from somewhere unlikely, this next signal is strange because it comes from nowhere at all. In 2004, SETI at home, a distributed computing project that lets volunteers around the world scan radio. Telescope data from their home computers detected something odd. A signal at 1,420 megahertz, the famous hydrogen line again, that popped up multiple times in the same region of the sky. It was faint, sure, but it kept showing up, again and again. In total, it was detected over 50 times, always in the same place. But there was a problem. That place, it was empty. There was no visible star, no known exoplanet, no gas cloud, no galaxy, just dark empty sky. Nothing that should have been capable of producing a radio signal. And yet the signal kept coming. Its name, SHG BO2+14A, is a technical label based on the location in the sky. But what it really meant was, we were hearing something we couldn't explain, from a place we couldn't see. Even stranger, the signal didn't stay still. Its frequency drifted. It's not wildly, but subtly. Almost like the source was rotating or moving relative to us. In SETI research, that kind of frequency drift is considered a potential marker of artificial origin because it matches what we expect from a transmitter on a spinning or orbiting object. If it were natural, the drift should have followed predictable gravitational patterns. It didn't. Instead, it behaved just unpredictably enough to keep us guessing. Some skeptics proposed that the signal was an artifact of Earth-based interference, maybe a satellite we forgot about. Others blamed bad calibration. But every test came up inconclusive. Nothing explained it. And remember, SETI at Home system was analyzing raw data from the Arecibo telescope, not from low Earth orbit. If it was interference, it had to come from deep space. So why did a faint, persistent signal, at the most watched frequency in the universe, keep showing up from the blackest patch of sky? It hasn't been detected again since 2004, but its multiple appearances over weeks of data make it hard to write off as a fluke. It's as if something briefly aligned with us, pointed directly at Earth, and then, just as we started noticing, vanished behind a cosmic curtain. Was it a probe? A long-range transmission? It's the universe playing tricks on our instruments. There's no resolution. It's no neat ending. SHGBO2+14A joins a growing list of deep space signals that follow just enough of our rules to seem familiar, but not enough to make any sense. Part 3. The ghost frequencies we can't track down. You'd think that with today's high-tech telescopes and satellites, we'd be able to track the source of any strange cosmic signal. After all, we can see galaxies 10 billion light-years away and spot black holes merging in real time. But sometimes, the most confounding signals don't come from distant galaxies. They come from right under our nose. They still manage to vanish before we can lock on. The two cases you're about to hear didn't just confuse astronomers. They almost fooled the entire planet. Number 6, the 1997 NASA alien beacon false alarm. It was supposed to be a test. In 1997, NASA's Jet Propulsion Laboratory was running routine diagnostics on a deep space communication antenna in California. Engineers were calibrating equipment, running code, double-checking, signal processing routines, and then it happened. The system lit up with what looked like a clean, structured signal coming from deep space, exactly the kind of thing SETI researchers dream about. It was strong, it was narrowband, pulsed in a way that screamed intentionality. Within minutes, phones were ringing across departments. Was this it? Had we finally made contact? The team scrambled to verify what they were seeing. For nearly an hour, the signal held. It wasn't noise. It wasn't a flare. It was something. Then someone checked the trajectory. The source of the signal wasn't coming from a star system or deep space void. It was coming from a very familiar location, SOHO, the Solar and Heliospheric Observatory satellite operated by NASA and ESA. The spacecraft was broadcasting as part of its normal operation. But a strange bounce in the ionosphere had distorted the transmission in such a way that it mimicked an intelligent deep space signal. Relief swept through the lab. But it was also unsettling. And worse, how many real ones had been dismissed as technical noise. That scare became a legendary moment in SETI history, not because we made contact, but because we almost believed we had. It taught scientists how careful they had to be with signal validation, but also reminded them of a darker truth. A real signal could look totally mundane, till you realize too late what it actually is. Number 5, the Green Bank repeater. A ping that felt personal. Most FRBs are isolated. A flash, a bang, then gone. Even the repeating ones typically come from billions of light-years away. But in 2015, the Green Bank telescope in West Virginia picked up something that didn't fit the mold. It wasn't just another FRB. This one had rhythm, purpose, structure, and it seemed to be aimed right at us. The burst came from a fixed position in the sky and repeated in bursts not chaotic, but almost patterned. Each ping was spaced in a way that reminded researchers of early digital transmission methods. At first, scientists assumed it had to be interference, maybe from a plane overhead, be a glitch in the telescope's new back-end system. But the pattern didn't match any known aircraft, satellite, or Earth-based technology. And every time the telescope moved away from the source and came back, the signal was still there waiting. It was as if something was locked onto Earth and pulsing like a beacon. It's not randomly, not loudly, just enough to be heard if you were paying attention. Over the following weeks, similar pings were picked up by other telescopes, and always from the same direction. This wasn't an isolated event. This was something persistent, and it was close. Not in our solar system close, but not galactically distant either. The estimated source was between 500 million and 1 billion light-years away. In cosmic terms, that's practically the next neighborhood. What made the Green Bank repeater truly eerie, though, was the way it behaved when under observation. Multiple teams reported that the signal would go silent as soon as they started recording in high resolution. It was almost like it knew it was being watched. That's not science fiction drama, straight from lab notes. Some researchers dismissed it as coincidence. Others thought it might be due to atmospheric conditions. But the signal's behavior felt intentional, like it didn't want to be caught clearly. To this day, the source remains unidentified. No matching galaxy, no star cluster, no black hole. Just a point in space that talks then vanishes. And unlike other repeaters, this one hasn't followed a predictable schedule. It appears to be listening, or perhaps waiting. Some theorists have even floated the possibility of interstellar probes devices built not to travel, but to wait silently in one place for signs of life. Beacons parked in the dark, quietly observing until they detect a response. Could the Green Bank repeater be one of them? We have no way to know. But what's clear is this: space isn't quiet. It's just speaking in a language we don't fully understand yet. Part 4. Signals too structured to be accidents at this point. You might be thinking, maybe these strange signals are just cosmic accidents, pulsars, magnetars, giant radio flares. But what if some signals go even further beyond power and precision into the territory of structure? Not just loud and clear, but organized. Not just noise, but language. That's exactly what scientists began to suspect with these next two mysteries. These weren't just random bursts. They hinted at patterns, repetition, and possibly intention. Number 4. The Soviet signal. A Cold War mystery from deep space in 1973. During the height of the Cold War, American intelligence agencies picked up a peculiar radio transmission. It wasn't coming from Earth, at least not directly. The signal appeared to be relayed through a Soviet satellite, but its origin? That's where things got murky. It was pulsing, structured, regular, too clean to be natural. The signal didn't match any known communication system at the time, didn't line up with military codes or terrestrial radio. And when analysts traced the satellite's position and its behavior, something chilling emerged. The satellite wasn't broadcasting, it was relaying. That meant the signal had to come from somewhere else, get picked up by the satellite, and then bounce toward Earth. Some in the US government feared it was a secret Soviet experiment, possibly an early attempt at quantum radio or deep space surveillance. Others in the intelligence community had a wilder theory. What if the Soviets weren't the ones sending the signal at all? What if they had intercepted something extraterrestrial and were quietly studying it? What made the situation more bizarre was the timing. The signal was picked up just days after a separate U.S. monitoring station had logged a burst of unusual radio noise from the same general region of sky, one that didn't match solar flare patterns, one that couldn't be traced to known satellites. The overlap raised eyebrows, but the Soviet Union remained silent. No public acknowledgement, no scientific paper, nothing. Then, as suddenly as it appeared, the transmission vanished. I'll repeat, no explanation. To this day, declassified documents only refer to it vaguely as non-standard frequency activity with atypical modulation. That's government speak for. We don't know what it was, and we don't want to guess in writing. Was it an alien signal? A failed experiment? Cover-up of something bigger? No one knows. And with Soviet-era space logs still tightly controlled, we may never get an answer. What we have is a short-lived, deeply suspicious signal that made both superpowers nervous and then disappeared without a trace. Number 3. The signals from HD 164,595, the one that checked all the boxes. In 2016, a Russian radio telescope picked up a signal from a star system 94 light-years away, known as HD 164,595. On paper, this sounded like exactly what SETI was built to find. The star itself is remarkably similar to our Sun. It's stable. It's not too young, not too old. And it even has at least one known exoplanet, Neptune-sized world that orbits at just the right distance to make researchers wonder. Could there be more planets? Could one of them host life? So when the signal came in, the scientific world took notice. It wasn't just the source that excited people, it was the characteristics. The signal was at 11 gigahertz, well within the expected frequency range for intelligent communication. It lasted a few seconds. It was powerful. Narrowband? And this is key, it wasn't a one-off from random data noise. It came in clean, precise, just once. And then silence. Initially, the Russian team kept the discovery under wraps. But once news leaked out, SETI groups around the world scrambled to confirm it. Australia's in California, Australia, Italy, all pointed at HD 164,595. But they found nothing. No repetition. No second ping. Nothing. Still, scientists were intrigued. Could it have been a military satellite bouncing a signal from Earth? Possibly, but unlikely, given the frequency and angle. Could it have been a natural phenomenon, like a pulsar or magnetar? Again, possible, but the signal didn't match those signatures. It didn't drift. It didn't wobble. It came in like a laser. What set this signal apart wasn't just its characteristics. It was the context, a sun-like star, confirmed planet. A signal with all the hallmarks of an engineered transmission. It felt like a textbook case for SETI. And yet, just like the WOW signal decades earlier, it refused to show itself again. Some skeptics argue that if intelligent aliens were trying to communicate, they'd send repeat signals, maybe even messages with encoded information. But others point out, if we were sending signals into space, we wouldn't beam them constantly. We'd pick a target pulse once and move on. Energy is precious, even in space. Especially if you're dealing with interstellar distances. A one-time message might be all you ever get. HD 164,595 remains quiet, but that one ping just seconds long continues to haunt scientists who can. T explained how such a perfect signal showed up exactly where it shouldn't have, and then never returned. Part 5. The messages that felt too intentional. We've heard strange signals from the depths of space, some that repeated, some that flashed and disappeared forever, some that seemed to mimic intelligence. But these last two, they don't just hint at intention, they scream it. Not because of how powerful they were, but because of when they arrived, how they behaved, and what they almost said. These aren't just unexplained signals. They're the ones that made even the most skeptical scientists pause. Because if you wanted to design a way to announce your existence to another civilization without starting a panic, this is how you do it. Number 2, the 2019 narrowband burst, a signal that almost said hello. In the summer of 2019, the Breakthrough Listen project, one of the most ambitious searches for alien life in history, picked up something odd. A narrowband radio signal coming from the direction of Proxima Centauri, the closest star to our solar system. That fact alone was enough to raise eyebrows. But then came the details. The signal was in a narrow frequency band 982 megahertz. That's not a frequency used by satellites. It's not emitted by known stars or pulsars. And it wasn't drifting like a natural source would. It was stable, focused, tight. The signal was picked up not once, but several times over multiple days. Always coming from the same exact direction. Now here's where it gets eerie. Proxima Centauri isn't just any star. It has an Earth-sized planet in the habitable zone. Proxima b, a planet where temperatures might allow for liquid water. A planet that could, in theory, host life. So to recap, a stable, narrowband signal, not used by human technology. Coming from the star system next door. From a location where an Earth-like planet exists, and it lasted for hours. If you were writing a sci-fi movie, this would be the moment the message starts decoding itself. Scientists were careful. They ran interference checks. They ruled out satellites. They checked local sources. And for a while, the signal remained unexplained. Then, months later, a possible answer surfaced. Some researchers believe it might have been caused by human technologists specifically, kind of Earth-based radio reflection bouncing off space debris. But here's the problem. No one can reproduce it. The signal still doesn't match any known local source. It remains a candidate signal, not confirmed, not debunked. It's just floating in limbo. And that's what makes it so compelling. Because if someone out there were trying to send a subtle eerie here without causing a media firestorm, they'd do it exactly like this. Quietly, on an unused frequency, from a nearby system, no message, just a ping, a cosmic knock on the door. #1 the 2022 unnamed pulse signal, the one that responded too well. In late 2022, a team using a new generation radio array in South Africa noticed something strange. A repeating pulsed signal in the 1.5 gigahertz range. At first, it seemed like yet another magnetar, flare until they noticed how the pulses behaved. Every time the telescope swept back over the source, the pulses adjusted slightly, almost like they were compensating. That's not natural. It's responsive. So the team did an experiment. They shifted the telescope's scan pattern. They changed observation windows. They even delayed transmission cycles. Every time they did, the signal adjusted too. Not dramatically, but enough to match the new rhythm. It was like something on the other end was tracking them. Then came the strangest part. In one final test, the team broadcasted a short, controlled radio pulse. Just the test beat back in the direction of the source. They expected nothing. But within 20 seconds, they got a return ping. Not identical, but unmistakably correlated. The signal had mimicked the timing. It was like tossing a pebble into a dark cave and hearing someone toss one back. The researchers didn't go public right away. They ran every test imaginable. Atmospheric noise, Earth-based interference, faulty timing algorithms. And after weeks of checking, they still had no good answer. The coordinates pointed to an area near the galactic center. Dense, complex, a noisy region full of radio traffic. But the signal stood out clear, regular, and far too adaptive to be coincidence. Eventually, the team published a preliminary report, careful not to make wild claims. They never called it alien. They never even called it artificial. But deep in the footnotes, one sentence stood out. The response correlation is statistically significant and warrants continued monitoring. It's science speak for. Something answered. To this day, the signal hasn't repeated. Maybe it was a coincidence. Maybe it was just nature playing games with our instruments. Or maybe, just maybe, it was the moment someone, somewhere, noticed we were listening. So what are we actually hearing? After all these strange signals, some loud, some faint, some gone forever, it's tempting to ask, what are we really hearing out there? Are we eavesdropping on alien technology? Picking up the dying breaths of cosmic giants? Or just misinterpreting the universe's static? The truth is, we still don't know. But that's what makes it terrifying. Not because the signals are scary, because we're not ready for the answer. We don't know what it would mean if even one of them was real. If even one was intentional. If even one was proof that we're not alone. What we do know is this. The universe is loud, not with sound, but with information, signals crossing space. Bursts of energy older than Earth itself. Echoes from the past or whispers from something watching. And every time we point a telescope at the sky and listen, we're asking the same silent question. Is anybody out there? If you made it this far, you're officially one of us, the curious ones. The questioners, the people who want to know what's really out there. So if you enjoyed this video, don't just vanish like the wow. Signal, hit that like button so YouTube knows you're listening. Share it with someone who stares at the stars and wonders what's hiding behind them. And of course, subscribe for more mind-bending top 10s every week. Because somewhere out there, the universe might be whispering back. Let's make sure we don't miss it.